Imagine a giant ball of fire that's been burning non-stop for 4.6 billion years, and it's still going. That's the sun. But have you ever wondered why it never burns out? How can it stay hot like a gas stove that never runs out of fuel? The secret lies in the sun's core, where a super powerful nuclear reaction happens every second. This isn't ordinary fire, it's energy from deep inside the atom. The sun's core is like a natural nuclear reactor. There, hydrogen atoms crash into each other at incredibly high speeds and pressure. The result, they fuse into helium while releasing a massive amount of energy. This process is called nuclear fusion. As long as there's enough hydrogen, this reaction will keep happening, and voila, the sun keeps shining. You might be thinking, okay, but how come there's so much hydrogen? Well, when the sun was born from a cloud of gas and dust in space, it got a huge supply of hydrogen, like having a giant fuel tank that lasts hundreds of millions of years. So it's no surprise that it hasn't run out yet. In fact, it still has enough fuel for another 5 billion years. On the sun's surface, the temperature can reach up to 5,500 degrees Celsius. But in the core, it's over 15 million degrees. At that insane heat, atoms lose their electrons and turn into plasma, a super hot state of matter that makes the sun glow. But weirdly, this fire doesn't need oxygen. That's because space has no air at all. While regular fire needs oxygen to burn, nuclear fusion doesn't. What it needs is extreme pressure and temperature. The intense pressure in the sun's core comes from its massive gravity. The sun's weight presses in on itself from all directions, like a giant balloon being squeezed from inside and out at the same time. But wait, why doesn't the sun just explode? I mean, it's got non-stop nuclear reactions inside. Well, that's because there's a balance between the outward pressure from the fusion energy and the inward pull of gravity. It's like a giant tug-of-war between two forces. As long as the balance holds, the sun stays stable, keeps glowing, and doesn't blow up. Sunlight takes only 8 minutes to reach Earth. But weirdly, it takes over 100,000 years for energy from the sun's core to reach its surface. How come? Inside the sun, energy moves very slowly, through a process like walking through a dense plasma maze, bouncing around, getting absorbed and re-emitted until it finally escapes as light. The sun is truly the center of life. Without it, Earth would be a frozen, lifeless rock. All the energy we enjoy, from body heat to solar electricity, comes from the sun. Even plants need sunlight for photosynthesis. So really, you and I are alive today thanks to the sun. But remember, the sun isn't eternal. One day, when it runs out of hydrogen, it'll change. Its core will collapse, and the outer layers will expand into a red giant. When that happens, it might swallow Mercury, Venus, and even Earth. But don't worry, that's still 5 billion years away. So you've got plenty of time to enjoy those sunny mornings. Now you know why the sun never burns out. It's not just an ordinary fireball, it's the coolest natural nuclear reactor in the universe. But our story doesn't end here. In episode 2, we'll dive deeper. How will the sun eventually die? And what happens after that? Will Earth be destroyed? Or is there hope for life somewhere else? Okay, now you know why the sun doesn't burn out. But everything that lives must eventually come to an end, including our sun. One day, the hydrogen fuel in its core will run out. When that happens, nuclear fusion stops, and the balance between gravity and energy pressure collapses. What happens next? Yep, the sun begins to change into a giant monster. As hydrogen fusion stops, gravity takes over. The sun's core shrinks, but its outer layers expand into a red giant. Imagine, the sun grows large enough to swallow the orbits of Mercury, Venus, and even Earth. If you're sipping coffee one morning and the sky turns insanely red, it might mean Earth has been swallowed by the sun. But wait, here's the good news. This process won't happen for another 5 billion years, so we won't be around to see the sun become a monster. But if you're the type who thinks long-term about Earth's future, here's the bad news. All water will evaporate, the atmosphere will vanish, and Earth will turn into a hot, lifeless rock. No more soap operas, no more fried rice. Super boring. In its red giant phase, the sun can still burn helium in fusion reactions. But that doesn't last long. After a few million years, the helium runs out too. And since the sun isn't massive enough to fuse heavier elements like larger stars do, it won't explode into a supernova. Nope. Our sun's ending is quieter. So what happens next? After the red giant stage, the sun will gently shed its outer layers. These layers form a beautiful cloud called a planetary nebula. It's just a name. It has nothing to do with planets. What's left behind is a small, dense, ultra-hot object, a white dwarf. A white dwarf is like the ashes of a fire that's burned out, but still glowing. It's about the size of Earth, but it can weigh half as much as the current sun. Super dense, like cramming 1 trillion elephants into a basketball. There's no more nuclear fusion inside, but it still shines, slowly fading until it goes completely cold. And when all that heat finally runs out, the white dwarf becomes a dark, cold object, a black dwarf. But in our still young universe, no black dwarf has formed yet. It takes hundreds of billions of years for a white dwarf to fully cool down. So for now, white dwarfs are still the sunset lamps of the cosmos. If you think this is the end of everything, not necessarily. It's possible that by the time the sun becomes a white dwarf, humanity will have moved to another planet, maybe Mars, maybe Proxima b, or maybe to space colonies. So even though the sun will die, it doesn't mean life has to die too. We just have to be smart and find a new sun. Fun fact: the sun is just one of about 100 billion stars in our galaxy. That means there are many other suns out there, some bigger, hotter, and even longer lasting than ours. So even if our sun dies, the universe still holds plenty of hope and potential for life. We just have to get there. So why doesn't the sun burn out? Because it's still young and fueled by nuclear fusion. But someday it'll grow tired, flare one last time, then slowly shrink and fade. This story isn't meant to scare you. It's a reminder. Everything has an end. So enjoy the morning sunshine while it still lasts. If enjoyed this kind of content, don't forget to subscribe and turn on notifications so you don't miss other exciting videos. Likes and comments will also help this channel grow even more. Thanks for watching and see you in the next video.